We now get to get excited for our next talk titled Programmatically Scale Human Preferences and Alignment in GenAI. It will address how to use alignment via RLHF or DPO to positively impact model performance and fit the model to your internal company preferences. Our speaker is an applied research scientist at Snorkel AI and is currently focusing on data techniques for scalable alignment and enhancing data quality in close collaboration with Snorkel enterprise customers. Please help me welcome Huang Tran. A fun fact about Huang, he just received a new batch of vegetable seeds with broccoli, peas, and mint. And he's very excited to get those seeds in the ground. That sounds pretty yummy. Huang, the stage is yours.
Thank you so much, Rebecca, for the warm welcome. And yeah, super excited about my new planting seeds coming in. Today I'm Huang. Super excited to be here today. I'm an applied research scientist at Snorkel AI. And today I'll be discussing how to programmatically scale human preferences and alignments in GenAI. So the key takeaways I want to go from the talk today: further alignments are needed. If you, after fine-tuning, please consider additional alignment techniques like RHF or DPO to further fit your preferences. Human preferences data are crucial in this process, which can be very resource intensive in enterprise settings. In order to streamline that human preferences process, you can try programmatically scaling it with Whisper Visions or the Snorkel solutions, reducing the resources required. So the agenda today: first, I'll be talking about aligning techniques, as I mentioned before, RHF and DPO. I also will mention efficiently scale SME preferences using programmatic approach, and finally discussing some results that we have. So part one, aligning language models with human preferences. So these are the two techniques. First, let's go way back into the ChatGPT moment. Back in November 2022, ChatGPT has taken the world by storm with the advanced conversational capabilities. 2 months after, ChatGPT reached 100 million users, which is incredible for any product. So what initially distinguished ChatGPT and make it a very likable choice among users? Now let's discuss the recipe to train the ChatGPT model. In addition to pre-training, which is learning the whole internet data, and supervised fine-tuning, or someone called instruction tuning, which is learning on supervised policy, like really high quality data, ChatGPT, the OpenAI team, did 2 additional steps: reward modeling and reinforcement learning from human feedback. So what is step 2, reward modeling, doing? They collect preference data from labelers to identify which response do every labelers like more. So like you rank different responses, different iteration of different response, and they rank different like I like this best, I like this worst, and they collect that comparison data and train a reward model. So the end goal is having a model that approximates human preferences. Then the last piece is the reinforcement learning piece, where for every response, for a new generated response, the model would have the new objective to optimize that reward coming in from step 2. So what does that corresponding to? So every response, you have a score. Low is not that good, high is good, and you want to optimize making that score bigger and bigger over time. And that will approximate, because the reward model is approximate what is a human preference. So you're actually trying to make your responses more human likable. And this is very important to make ChatGPT really likable among users. So alignment steps are crucial to develop LLMs that follow your customized preferences. There's also alternative to RHF. This is recently new, DPO, direct preference optimization. This is coming from the Stanford lab. So there's some, here's a diagram that you can see the differences. So in the similarities, you see both approaches utilize a preference data set. So you see here the preference data set in both cases. But the differences is, instead of doing the reward model and the reinforcement learning piece, as I discussed before, DPO update directly using the preference data. So it increased the relative likelihood of chosen to rejected response. So what does this mean? You want to generate response that closer to the chosen text and further away from the rejected text. So you want to increase that gap. So the chosen text will become more probable and the rejected text is become less likely to be happening. Note, this talk is not about DPO or RHF or reinforcement learning, but more about how you can scale the preference dataset, which is happening here. So this is a very limited comparison between DPO and RSF. Computational DPO is lighter because you don't have to sample from the language model. But because you're optimizing against the preferred text, so you're actually limited by some constraint. Whereas for RSF, you actually only constrained by the reward models, like the reward score. You only try to optimize it. So you have more freedom to explore. And the output model, we have reinforcement learning, or we have GPT, Claude, Llama, and Gemini using the same technique, RSF. And DPO also show very strong, promising theoretical results, contributing to Zephyr or Tulu. Note these two models, their DPO recipe also use responses from other language model. So that's just a small note. So more experiments are needed to comprehensively compare the performance of different approach. But a common theme is they both require data that reflect preferences. And there's some caveat with preference data. It's very resource intensive, very time consuming. It's an iterative process because your model keep on improving after updates. So your preference data need to be also be updated. So in the case for Llama 2, they actually update their preference data weekly, which can correlate to very time intensive, resource intensive process. You need to continuously collect that data. And the current alignment axes are very simple right now, like helpfulness, honest, harmless. But the challenge lies in scaling alignments in more advanced enterprise customization for the internal policies. So you need a scalable way to create your customized preference data. And now we'll talk about that piece, how to efficiently scale that preferences using programmatic approach. So the end goal of this process is you have data that reflects human subject matter experts' preferences. So you can either approach it by two primary techniques. You can do pairwise or ranking preferences. So between these 7 responses, which one do you like best? And you can rank the response. The requirement is you need multiple responses for the same prompt. You can also approach it from the second approach, which is more like a high-low quality classification. So you're trying to classify if a response is high or low quality or like different varying ratings. Multiple responses for the same prompt is optional. So Snorkel thesis is that subject matter expert need to be closely in the loop to align the data development process with the business needs. What does that entail? You need manual annotation. You need a small subset for just validation and just gaining the expertise. You also need to connection with your knowledge base to enhance contextual. And the most important thing is instead of just manual labeling one by one data, you should create labels with functions. So desired text patterns, formats, prompts, external metrics, models, combining all of these to label more scalable. And the Snorkel team will combine denoise, the Snorkel techniques will combine denoise various signals to provide quality label data. So let's go into more details. So instead of manual labeling one by one, allow SME to create labels with functions to express their preferences at scale. You can imagine text pattern, prompting with language models, or using external specialized models and metrics. So this labeling function can be noisy, they can be conflict, but the Snorkel the platform will combine and denoise these various signals to generate a high quality label data set. So let's go deeper into each piece. First, some text pattern. Of course, there's some examples. We support more fine-grained customization, but you can imagine responses with, you prefer responses with like list-like format, like you want to like look at a list or different bullet points. You want your chatbot to have answer follow-up questions. Or if for marketing purposes, you want responses that mention your company name at least X amount of times. Or just like different responses that follow your workflow, your customized workflow. You can also like downgrade responses with like safety concerns or different format that you don't want to. Like if you answer a question with a question, that's not good. So you want to like move away from the response. So these are some text pattern you can use. Also, you can also use prompting with language models. So in addition to label with only text pattern, you can also prompt language model to support labeling. The common themes we see are like external ratings. From 1 to 10, rate your response, or align to more arbitrary but generic characteristics like workflow, safety, helpfulness. Or you can directly Q&A on your data to support decision making. Finally, you can also utilize existing model if you already built them before, or if the metrics that you have in mind. So for example, you want low perplexity, you want low toxicity score because you don't want any toxic response. You want high sentiment score because you want customer to be more happy. You can use external models if you already built them, or different teams already built some existing models. So you can always reuse them. For example, you want like some finance related models, you can also use models like FinGPT, for example. And you can do external features like key topics, anything else, everything is fair game. So the both functions are only examples. They can be noisy, they can be conflicting. The Snorkel flow will combine and denoise those signals to generate a high quality training set. We also support more customization to build your custom models on your data that actually reflect your preferences. So let's come into some results. So the collaboration of SME and Snorkel techniques is very crucial to scalably achieve your data that actually reflect of your enterprise. Some other benefits are scalability. So because you label at scale, it's faster, it's more efficient, 45 times faster in the case study with a bank. It's more tractable because we're labeling functions. So you can trace back to origin and making more auditable and making the error connections much more easier. And it's also transferable. So when you start a new updated data on a new alignment access, you don't start from scratch. You start from the existing signal you have because the functions are transferable. You can easily transfer those signals into a new development process. So these will help with resources, customization, enterprise ready, and the iterative process you need. Here's some results. You can build reward model with unlabeled data programmatically. So back in July 2023, we already built programmatically label high or low quality responses from DALL-E and Open Assistant open source data. So two developers actually accomplished this in one day because we do it like through programs and we avoid the need for weeks or months of manual annotation. Then using the above labels, we develop a quality scoring, or you can call it a reward model, to classify and scores if a response is high or low quality. So here's some example function that we use to classify if it's high or low quality. Text pattern, individually, we prefer list-like response, prefer saying thank you. We did downgrade on language models, answer with questions. We also use metrics as mentioned above, low perplexity, or we think about like high cosine similarity between your question and responses. So your question and your response need to be like very similar. And also because the task is very dependent, like very diverse. So we also create a model, also programmatically, to classify task type. So is it a question answering task? Is it a chat? Or is it a summarization task? And we use these tags to control for like task dependent quality. So you can imagine you want control for length in summarization task. You want to give control for conversation patterns in chat. And also link the blogs here if you're interested in digging in more. How does that reward model, now we have that reward model coming in. How can we use that reward model in the final alignment piece? Here, we propose doing DPO. We're choosing DPO right now because it's more computational friendly, but we expect the same results for the reinforcement learning approach. So you can DPO on your self-generated response with preferences provided by the Snorkel model. So if you remember from the DPO process, you have a chosen text and you have a rejected text. So first, we have a data set with 10K only prompt. So we're only using the prompt section, no responses from other language model. So only prompts, and we choose the base model is a Mistral instruct. We generate responses. For each prompt, we generate 5 different responses. Then from these 5 responses, we re-rank them using the Snorkel, the reward model from the previous steps. So we re-rank them. And then for the best one, we take that as the chosen text. And then we randomly sample among the rest to have a rejected text. And we feed that into the DPO process. Originally, on Alpaca eval, which is a benchmark for how is it likable, how good it is in following instruction, the base model have 77.8 on Alpaca eval. After the DPO process, on the self-generated data using the Snorkel model, the model actually improved 9.5% to become 85.2 score. This whole process is developed under one day, and not using outputs from other language model. So again, you generate response, you re-rank them using the Snorkel model, and then you get the chosen and rejected text for a DPO process. Also, there's also importance in the data selection effect. So before we're using 10K prompt, this is only using 2.5 thousand prompt, just for scaling and experimental purposes. So now, before we do version 1, which is random sample, right? But now we can also do, because we have all the scores and all the rankings, we can do a lot more things. So we can choose the best negative response, which is the best response that is still labeled as low quality. Or version 3, we choose the worst response as a rejected text. So again, same DPO process. We actually see that hard negative sampling, which is version 3, selecting the worst response as a rejected text, is actually performing better than if you just do random sample. Like you see 84 versus 81.5 score. And the access to a relative score is very useful to optimize performance, and you can do more customization with this. So more benefits if you still using the reward model. Yeah, to recap some key results, with only a 10K prompt-only dataset, no learning from responses from other language models, we achieve a 7.4 points or 9.5% increase on our buck eval in under 1 day. It's also competitive against alternative. So if you do DPO from preferences from Snorkel, you receive 85, where if you do like the open assistant reward model, it's around 83.31. And remember, like the Snorkel model was built with under 1 day with like unlabeled data, and not using any like public labeled data, and very customizable. And 85 score is very competitive on also the Alpaca eval benchmark. Claude is around 87, whereas GPT 3.5, the original version, was around like 82. So that's just your references. The learnings is also language model can improve to DPO on its self-generated responses with preference score coming from external models. And you can do it for customization to reflect your enterprise preferences. The goal is not to compete with unpublic benchmark, but more of these experiments are to reflect our approach, some of the perspective and results that we see in our like internal engagement with leading enterprises. Additional results. So in DPO, hard negative sampling can be useful, performs better than random sampling. So you need more comprehensive rankings, or you just like reward model score better. Additional benefits is you can also use the reward model to select high quality data for supervised fine tuning. So remember that there's a paper Lima by Meta, which already showed that high quality supervised fine tuning data are super important. So utilize the same reward model that we built earlier. We can select which data is high quality to train the model. So we train a Red Pajama 7B model, which then outperforms 3.5 to 10 points, again, if you train on all data. So training a subset of high quality data is actually performing better if you train on all data. I also link the blogs below if you're interested. How does that transfer to enterprise settings? At a Fortune 500 telecommunication company, where we collaborate to build a chatbot, still same techniques involving SME in the loop to programmatically identify which one are high quality data, which one adhere to the internal workflow. And the result is we achieve a 17-point boost on F1 score. And we actually outperform using ChatGPT alone in predicting high quality. So very transferable into like enterprise settings. And because they try to do like customized version for their chatbot, which is even more customizable and the reflective of their workflow. So coming back, that's the key takeaway from today. To optimize your model response, you need further alignments. To enhance your enterprise policy, you need human preferences. SME in the loop, super important, despite being very costly and time consuming. And you can use Snorkel technology and our data-centric workflow to make it more scalable, more tractable, and transferable, still keeping the SME in the loop to make your language model more closely aligned with the preferences. That is the end of my talk. Thank you so much. Here's my contact. I'm happy to connect either from email or LinkedIn. Thank you so much for tuning in today, and I hope you have a great time. Thank you so much.